Hi, my name is Pradeep Dhaliwal. Welcome to this MCAT Science Review video on atomic orbitals and quantum numbers. You're going to learn about the four quantum numbers, n, l, m, and s, in their usual order. After watching this video, you should be able to describe the shapes of a few different atomic orbitals and describe their corresponding quantum numbers. And you'll learn to answer questions such as, an electron in a sodium atom in its ground state could be assigned which of the following quantum numbers? Let's start by looking at n, more commonly known as the principal quantum number. It's used to describe the energy level of an electron orbiting a nucleus. So in this Bohr diagram, electrons on the first line would have an n of 1, on the second line would have an n of 2, and on the third line would have an n of 3, so on and so forth, because n can be any number that's greater than 0. Now let's look at L, the second quantum number, also known as the Azimuthal quantum number. It's used to describe an electron's subshell. So for instance, this s subshell at the first energy level can be labeled 1, 0. This s orbital at the second energy level can be labeled 2, 0. Whereas this p orbital at the second energy level can be labeled 2, 1. So what you should notice here is that a different azimuthal quantum number corresponds to a different subshell. S is 0, P is 1, D is 2, and F is 3. And even though L can be any number from 0 to n, these are the only four that you're likely to see on test day. Next, let's look at the third quantum number, m, also known as the magnetic quantum number. This quantum number describes the orbital that an electron is in. So if we look at that 2, 0 s subshell from a moment ago, it's only got one possible orbital, and so the only possible third quantum number it can have is 0. On the other hand, if we look at the p subshell, it's got three possible orbitals. We can refer to those as 2, 1, negative 1, 2, 1, 0, and 2, 1, 1. A pattern you might be noticing is that m can be any number between negative L and L. And even though they've got much more complicated structures that you don't need to know for test day, it is worth knowing that the d subshell has 5 orbitals that range from negative 2 to 2, and the f subshell has 7 orbitals that range from negative 3 to 3. Finally, let's look at s, the fourth quantum number, also known as the spin quantum number. This, as its name suggests, is used to describe the spin of an electron. And don't worry, you don't need to know what spin actually is for test day. But if we look at that 2, 1, negative 1 orbital from just a moment ago, it can hold 2 electrons, one of which would be labeled 2, 1, negative 1, 1/2, and the other of which would be labeled 2, 1, negative 1, negative 1/2. Because s can either be 1/2 or negative 1/2, and it's just used to differentiate between the two possible electrons within each orbital. Because any orbital, whether it's an s orbital, the first p orbital, or the fifth f orbital, can all hold exactly 2 electrons. Now that we're nearing the end of the video, let's come back to that question from the beginning. If we know only one of these can describe an electron in the sodium atom, then the other 3 have something wrong with them, and let's find what it is. You might notice that the fourth quantum number in C is 1, so we can eliminate C because the fourth quantum number can only either be negative 1/2 or 1/2. And if you look at D, you might notice that it's got a second quantum number of 1, but a third quantum number of 2, which is impossible because that third quantum number should be between negative 1 and 1. So we can eliminate D as well, which leaves us to pick between A and B. If we look at the first 2 quantum numbers in each of these answer choices, A is describing a 3s orbital, whereas B is describing a 3p orbital. And even though they're both otherwise correct, the 3p orbital isn't filled in a ground state sodium atom, and so B is eliminated, which leaves us with the correct answer choice, A. Now that you've reached the end of this video, you should see if you're ready for test day by filling in this chart. N is more commonly referred to as the principal quantum number, and it describes the energy level of an electron. Its possible values range from 1 to infinity. You might hear L referred to as the azimuthal quantum number, and it describes the subshell of an electron. Its possible values range from 0 to n-1. M can also be called the magnetic quantum number, and it describes the orbital of an electron, with possible values that range from negative L to L. And finally, S can also be called the spin quantum number, and it describes the spin of an electron, with possible values of either 1/2 or negative 1/2. As long as you remember all of the information on this chart, you should be in a great place for any quantum number questions that you might come across on test day. Congratulations, you've reached the end of the video. By now you should feel comfortable explaining all 4 quantum numbers, and how they're used to describe the locations of electrons. If there's any part of that you're still confused about, feel free to go back and rewatch the video. Best of luck on your MCAT.